So, hi everyone. Today is our seventh webinar for Energy Management and Efficient Electrification series for Ontario municipalities, and it's about operating for energy efficiency for water and wastewater treatment plants operation. And today we have two guests, Stephen Dixon and Andrea Dwight.
Right. Good. And I'm also in the house, Christian Tam from LAS.
Christian, I'm sorry.
That's okay. I'm not going to do much talking. Well, good afternoon and welcome everybody. Can you believe it? It's June, 4th of June. I don't know where all the months went to, but anyway, the reality is we are mid-year and we're offering this program. My name is Christian. As I said earlier, I work for LAS as a municipal program specialist. At LAS, what we do basically is develop programs and services for municipalities. So if you're a municipality and you're on board, you are attending this webinar, or even you're a public sector, you're attending this webinar, we cater for you. And the three main reasons why we do this, programs and services is to help municipalities reduce cost, save money, and build capacity. Energy training, of course, is one of the programs that we do develop. What you're going to hear from Stephen and Andrea is just a taste of the energy training workshop that we do offer to municipalities. So if there's an interest, this is just a teaser. We can do a full one-day workshop. We come on site, incentives available, and we will do a workshop. So let us know, or let me know. My email will be at the end of the slide. So without much ado, I hand over to Steve Dixon and Andrea to take us through the day.
Thanks very much, Christian.
Thank you.
Just got a quick little bit of housekeeping here. So we'll use the chat if there's any questions that come up. We'll try to take those as we go. And so we, don't hold your questions. If there are more complex questions, maybe we'll deal with those afterwards. And there's actually, for very, very, very complex questions, there's actually an opportunity afterwards. Mintu will be sending you out a form for coaching, and that gets you up to 2 hours of support from Andrea or myself or both of us in conjunction with this webinar. So, we could certainly review things for you, and it's a bit of free coaching. So please take advantage of that for the much more complex issues. We only have an hour here today, so Q&A in the chat, because I don't think there's a Q&A window there today. All right, and just a quick little. Andrea introduce herself in a second. Many of you probably know me. I'm an energy guy, being that way for 44 years. I actually have done work in a number of wastewater and water treatment plant operations. I'm, in fact, not an expert at that. That is, in fact, Andrea's bailiwick. Andrea's quite well versed in water and wastewater treatment. And so I'm going to let her introduce herself. I'm the energy guy. I'm going to bring the energy perspective. Just to let you know, Kristen, you talked about workshops. We've actually done treasure hunts, energy treasure hunts, which are basically collaborative operational searches for opportunities in a number of water and wastewater operations, both in Ontario and elsewhere as well, northern and southern Ontario. So that's another opportunity you can reach out to Christian about is having one of those types of things. And a lot of the examples we're going to bring here comes both from those workshops that we've done, but also from Andrea's consulting. So Andrea, quickly, a little bit about yourself, and then I'll start rolling.
Yeah, sure. Thanks, Stephen. Hi, my name is Andrea Dwight, and I run a small firm called Blue Sky Energy Engineering, and we focus on energy conservation in industrial plants and for municipal clients as well in the water and wastewater sector in particular. In addition to energy conservation, as Stephen has mentioned, we also focus on process engineering in wastewater. So we have had a fair bit of experience, not only looking at energy opportunities, but also process optimization as well. Thanks.
That's great. All right, so I'm going to start off a little bit on the sort of the more generic energy side, looking at sort of a process for looking at your operation, starting with sort of considering the cost, carbon, and energy balance, and that's kind of an interesting one. Touch on a little bit about it, benchmarking. ISO have actually done some great work in terms of benchmarking plants in Ontario. I'll talk about how we can use performance analysis within sort of understanding how a facility uses its energy, whether it be water or wastewater facilities. I'll show you a little bit about how to break down the energy use, and actually I'll introduce you to following that, recipe archetypes, which are really good for actually getting a handle on, how a plant might actually use energy. It's a sort of an end-to-end analysis. Andrea and I developed a couple of them, 2 for water and 2 for wastewater. I'll describe those later on. I will finish by talking about sort of the options for opportunities, waste, energy you don't need to use, efficiency, how well you convert the purchased energy to the end use form, and then some supply side options, renewables and heat recovery and things like that. I'll then turn it over to Andrea, and actually this is, even though there's like 2/3 of the agenda here is dedicated to what I'm going to do, it's going to probably be a third of the time on me and then 2/3 on Andrea. She'll start off by digging into those process systems and some of the measures that we found, how we approach it, and then looking at the support or the ancillary systems. And although process can use a lot of energy in these types of plants, what we found though is that there's always a lot of opportunities in those support systems. Sometimes they don't see the same kind of focus as the process systems because it's not the core business of the plant. So great opportunities there as well. Andrea will jump in as we go through if she hasn't. As I said, put your questions in the chat. I always like to start any examination of how any facility uses energy with these 3 pie charts. Today, I think most organizations that are looking, and many people online here today would be focused on 2 things. It would have 2 goals from your organization. Neither of them are energy, I suspect. Although I'm kind of saying that tongue in cheek, because really it's about cost and carbon. Energy is the intermediary, right, that costs money and carries carbon. So what I like to do is to take the energy bills, break them down in terms of energy units. So and this is actually this is a wastewater treatment plant we did recently. So, 67% of the energy units was from electricity. 91% of the cost, right, comes from the electricity, 9% on that natural gas piece. But when you look at the carbon side of it, that's where you see that huge piece coming from the natural gas, because obviously in Ontario, even with small changes that are taking place now, electricity is still relatively, free of carbon in that sense. So it's always good to start with these graphs, because if you've got goals to reduce carbon, reduce cost, you got to do both. You got to work at both sides of the house. You can't just look at one or the other. And the same thing goes, maybe even more so, in a water pumping station or maybe a water treatment plant. This is actually a water pumping station. But there, there's a small amount of natural gas used for heat and maybe even a lot of electricity used for heat in those situations. So it's largely weighted in terms of electricity and energy and cost towards electricity. But again, even though that's a small amount of natural gas, there is still a good chunk of carbon, and you're going to get some opportunities in there as well. So obviously starting with these types of perspectives really kind of sets the stage for what you might have to do, what you're going to go looking for, the types of opportunities you're going to get into. So I always like to use these as a starting point. All right, moving on. So the first thing I would do, and Andrea, this is the first thing you would do, is whenever we approach one of these plants, we say, okay, how much energy do they use, and how does that compare to the amount of process or what they're doing, right? So typically, in a wastewater treatment plant, which I'm focusing on here, you would look at something like equivalent megawatt hours per megaliter, gigajoules per megaliter. There's various different units, but basically the numerator is the energy and the denominator is the volume of water or wastewater or processed fluids that are going through that facility. Certainly, I'll talk a little bit about performance analysis, looking at how that number changes over time. But there certainly are ways within even portfolio manager to compare your plants, other plants, but also sector studies. And that I'm going to, go ahead.
Sorry
Andrea.
to interrupt, Stephen, but there was a question in the chat. And I think we can answer it quickly now. 2 questions actually I see here. One from the previous slide, which was, where is gas being used in a wastewater treatment plant? And typically it's used like in many other facilities in your rooftop units to heat some of the spaces on offices, but it's also used in the process often for the digesters because they have to be heated. So often you'll use natural gas to heat a boiler water that then heats the digesters. Sometimes you can use the biogas that comes from the digesters to then fuel the boilers, but often it's natural gas as well. There's often a few different places it's used. There's also
that question comes from, I'm just going to help you here a little bit. That question comes from Max, and Max works within the dairy industry. So the type of wastewater treatment plants or treatment plants he's operating are pretty specific, correct, Max?
Yeah, that's true. And I was just like, I've not really looked at our wastewater treatment plants too much, so this is a bit of a learning for me. So thank you for that.
Yeah. And I see you have a question, Max, on dissolved air filtration, and I'm going to leave that to the end if we have time, and if not, I'll contact you afterwards and we can get to it.
Yeah, I appreciate
okay.
that. I figured it wasn't really a question for right now, but I wanted to get it out before I forgot. Thank you.
Yeah.
And no
Great.
worries.
That may be a good thing for the coaching piece, so that's good. All right. So portfolio manager does have allowance for these types of plants. Probably not quite as deep as you would be able to use portfolio manager for other buildings as a benchmarking tool, but certainly sector studies. And the ISO link down here is a study that the ISO did a few years back, which actually does sort of dig into the energy use in these types of plants. And I'll give you a sample of what that might look like here. So this is actually a slide that I typically use in many of the workshops that we do, where you sort of lay out for wastewater. In this case, we're focusing on wastewater treatment plants. We're looking at energy units of equivalent megawatt hours per megaliter. And so here we have sort of the range of values, right? So most of the plants are operating in that range of 0.5 to about 1.8, right? But there are outliers beyond that as well. So I always like to get an idea of where a plant sits. At the Good Report, when you receive the PowerPoint in PDF format afterwards, you'll be able to jump to that link and have a look at that report, see where you sit. So benchmarking is always a really, really good place to start. We actually, Andrew, we did a treasure hunt on a plant that was operating at 0.4 there a little while ago. We still found about a 15% opportunity through a lot of operational means. So just because you're operating really efficiently today doesn't mean you can't find opportunities even then. So the other thing I like to do is to actually look at the monthly data. And for those that have seen me before in other webinars, I'm a big fan of performance analysis, where I do use a regression analysis to understand the relationship between energy, in this case, it would be electricity, and plant flow, and how hot or how cold it is outside. In this case, how hot it is outside is a significant variable. So I was able to develop a model. This is actually a plant that we actually went into and did one of our engaging workshops, what we call the energy treasure hunts. Was able to actually develop a model relating, plant flow and heating degree days to the electricity. I had an R-squared on my model of close to 99%, which is pretty scorchingly good. And then I was able to show at some point where they actually took off their consumption or their performance increased in terms of the amount of energy they're using. And it turns out there was a process change in there, but they were able to actually quantify that process change with it. So it's always good to go back and look historically. Sometimes it doesn't go up, sometimes it goes down, and you've made improvements, you don't know about it. And this wasn't a bad thing for them, but it allowed them to establish a new baseline for performance monitoring in the future. So comparing a plant to itself over time is always a good thing. You can do it on wastewater, which is what this is, but also on water treatment plants as well. I always like to make
Stephen,
use of the interval data.
Stephen,
Oh,
we
go
have a
ahead.
question, an interesting question here. Maxim say, why and how is weather a driver to electrical consumption?
Well, that's an interesting question. I mean, Andrew, within the process, there's probably reasons for that in terms of maybe the blowers, for example, right? The volumetric efficiency of the blowers changes with
Winter to
outside
summer.
temperature. Yeah.
Seasonal.
But also, if that plant is using electricity to heat, right, certain parts of the plant, then it's going to have some relationship to weather in that case as well. So, it's sometimes those relationships are surprising, right? And you don't realize they're there, and that drives you towards opportunities. I've seen that in a process situation where they didn't think weather was a driver, but I showed them that it was. Then they started to dig down and find out why. There was opportunities to isolate the process from the weather. So, sometimes these little analyses can be a little bit uncovering.
Well, and the other thing that we should point out, Stephen, I forgot to mention this earlier to you, is that I use red screen as well, not only to compare electricity use to weather, but electricity use to plant flow. So obviously, when you have wet events or if you have higher plant flow, your pumps are going to be working harder and longer. And there are always really good correlations in wastewater treatment plants in particular between flow and weather and electricity use.
You can see that here. The green line is plant flow, the blue line is electricity, the red line is the weather. So they're both significant in the equation for electricity. right? And red screen does it really nicely. You get multiple variables. So Max, you probably already know that. All right, so the other thing I'd like to do is look at interval data. So I like to look very finely, right? So I might be using 15-minute data, and this is a week in the life of a plant. And here we see, different modes of operation of the plant. In this case, what I was trying to do is to determine whether precipitation had an impact on the electricity consumption of the plant, right? And obviously it does, right? Now, it was different for these two events, and that actually allowed us to uncover some, I guess, peculiarities about the way they were receiving flow into the plant. But again, Red Screen has a great tool for bringing precipitation data alongside electricity data in this case, and understanding what that means about how the plant is actually operating. Right. So not just looking at your overall data as benchmarking, not just looking at your monthly data, but now looking at that fine data. And Andrew, you've got some great examples toward the end there of where you did this in plants and what you found and the savings opportunities that came out of it because of that surprising thing called electric heat maybe in a plant. The other thing, if your plant's big enough, obviously in Ontario, under Class A, meaning if you're over a megawatt, you basically pay the global adjustment based on your contribution to the 5 top peaks. The interval data is very important there. We've done a lot of work with water pumping operations, larger water pumping operations, where we actually are looking at their impact and designing strategies for overcoming the basically the impact that they're having on those 5 top peaks. That is managing their response around peak times. Worked with a couple of water pumping operations, and they found it extremely valuable to be able to produce these graphs and put them in front of operators. The operators start to understand what they can do. So again, that's all part of what we call our energy treasure hunt, where we're working collaboratively with the operational folks in the operation. It's about really bringing together the energy knowledge with the operational knowledge of the plant. I have a fraction of the knowledge of the operation of a wastewater or a water pumping operation than the operators do. They have a fraction of the knowledge of energy, but if we can come together collaboratively, I think this is where we can really find a lot of opportunities. And so I use, again, the interval data to do that. This is kind of neat. Polka dots. No, this is actually what we call a heat map, where I can look at the whole year. And this is from a real, I think this one is from a wastewater treatment plant operation back in 2022, 2023. So here we can actually see the whole year. Every pixel there is basically an hour in a week, and then we've got weeks across the year. So it's very easy to look at it. Now, in this case, it's relatively random, but sometimes you can see some very interesting patterns that emerge. So again, really good tools, digging into interval data, really understanding how your plant's using its energy. Understanding where it's all going, right? And Andrea, you'll speak to this one later on, realizing how much you're actually using for space heat. Maybe it's a small percentage, maybe it's a large percentage, but being able to break that down. This actually comes from some of the archetypes that we've created in Red Screen, which allow you to kind of look at an archetypical or a very typical plant, and then maybe start to model your own plant using these tools as well. So Red Screen does provide a pretty detailed breakdown. So this is kind of like an audit in a box in a sense with the archetypes that are available. When it comes to opportunities, and Andrea is going to get into the bulk of them here, but basically what I like to always think about is 3 priorities, right? Waste is the first priority. Energy you don't need to use. Turning things off, turning things down, and properly controlling things. Andrew will go into the details, say, of aeration and exhaust and ventilation in these plants, but basically it's about energy that, we don't need to use. Like there's no use in over aerating, right? Because that can actually be as detrimental as under aeration too. So again, making sure that we are meeting the need head on, right? And whether it comes down to lights or temperatures or aeration or other types of energy use within the process. Improving efficiency, how well we convert the energy from the purchase form, largely from an operational standpoint. If we have combustion equipment, we want to make sure that we're keeping it tuned up and that we're controlling that equipment properly. Obviously, in general, we're moving away from combustion and the use of natural gas, but there's still a lot of opportunity in those types of systems. Andrea, you talked later on about looking at it from the energy lens and realizing that pumps are not being operated in the right part of their curve, and resequencing and optimizing sort of the operational strategy of the plants and using that to find opportunities as well, without actually changing a pump, just utilizing pumps in a different way. So you're actually optimizing where they are in their curve. And then there's all the technological opportunities, but I like to focus on the operation, maintenance, and then the optimization opportunities first before we spend capital. But Andrew, you've got some ideas around how we can use technology, right, to improve using capital as well. And finally, the supply side, right? So after we've reduced the waste and improved efficiency, then we want to turn our attention to things like the renewables. I put heat recovery in this category, the use of heat pumps, even the biogas alternatives, obviously. What are we going to do, with that biogas? Can we use it? So there's a couple of questions here. How long can a plant turn off the blower to peak shave without compromising aeration? There's a great question there, Andrea.
Well, that's not one I can answer in 1 minute. Every plant might be different. And there is honestly a period of time that you can manage a process without aeration. But here's another problem. Not worrying about DO, you have to worry about all the solids dropping to the bottom of your aeration tank. So certainly you can pare back your blowers, but you really shouldn't turn them off because you need to keep all the solids in suspension, if there are any, especially with a fine bubble. So I'm not going to get into that today, but I can take this offline and talk to you about how you might want to determine that for yourself on your specific process.
Yeah, that's great. Well, thanks, Jesse. And then I think one of the folks from Z3 Controls are talking about some of the things that they've done with this. So have a look at that comment in the chat and maybe consider talking to those guys about some of the things, those folks that they can help you with. So,
Stephen, there's another comment here from Z3 Controls.
Yeah, that's what I was just talking about. Yeah.
Yeah. And they say, I agree with you. The comment is that you have to get to the interval data. So it's great to start with monthly data, then to hourly, but you really need to get right down to the brass tacks when you're really watching, looking for optimization opportunities. So I agree with
Sometimes you can get 5-minute data. I've seen 5-minute data, but you're right. I mean, getting closer than that, and you've got some good systems to be able to do that. When determining energy that uses kilowatt hours reading, what would you recommend? If you can separate that, that's fine, but you may not be able to separate. If you can, if you're calculating your metrics, your KPIs, and you can separate that, I would have to go back to the study that was done by the ISO, the Save on Energy study.
I'm sorry, Stephen, which question are you answering?
This is the one about when determining energy KPI for a water treatment plant that uses kilowatt hours for heating during cold seasons. So basically the idea is that do you put in your numerator, do you put all the energy, including the pumping and the heating energy, divided by the flow, or do you separate the two and do it that way, right? And it really comes down to what you're comparing it to, right? So if you're comparing to a data that actually contains it mixed together, then obviously, yes, you would want to mix it together. If you simply want to look at the energy for pumping, it's pumping specific energy in a water pumping station, then I would separate that out. So it really depends on the situation and whether you can actually separate those numbers effectively. You can sometimes separate them using regression analysis, and in the type of analysis that I did earlier would allow you to do that. So cool. Blower 10. Okay. Cool. All right. Well, Andrea, we're going to move on to your section here pretty quickly, but I do want to point out that if you can see this, even if you don't have a Red Screen license, you can download Red Screen and you can go and have a look at the archetypes that are available in there in the virtual energy analyzer. And these are 4 predefined buildings. We built 2 for low energy and we built 2 for low carbon, 1 each for water and wastewater treatment. And so they actually get into a lot of detail. Andrew, we analyzed a number of plants when we did these, and we tried to create these archetypes that were, again, the definition of the word archetype is something that's very typical. But not only do we show where all the energy is going, but in those we actually outline a number of key opportunities. So you can get a sense for what those opportunities look like, and maybe for what the financial results look like for those types of opportunities as well. There's a water plant archetype, so we have one for, or a couple for water and a couple for wastewater as well. So have a look at those if you're interested. They do kind of give you a leg up. If you haven't done an audit on one of these operations, it's a good kind of a pro forma layout for doing an audit on an operation to figure out where all the energy is going and then what the opportunities can be. So that leads us to some more detailed discussion on some of these measures. Andrew, you're going to go through and you're going to look at pumps, you're going to look at blowers, aeration, the UV systems. You're going to go into, maybe some of the use of variable frequency drives, the idea of, even though you can't reduce the amount of pumps, and maintain your certification, you could add a pump of the right size to do a particular function, right? Making sure in your UV systems that you're not, basically you have turn down. That is, do you actually need all the power to the lamp all the time? Is there a way to actually modulate that or moderate that based on what the requirements are? And that, to a large extent, that whole idea of matching the requirement is a strong theme of a lot of things that you've done in these plants too, is to optimize the operation.
Very true.
So, Andrea, I'm going to turn it over to you. I'll put your
Sure.
first slide up, and you can jump to yours. Oh, you can
Yeah,
share
sure.
your slides.
Sure, I'll jump to mine. Okay, so can you see that, Stephen?
We
went
can.
back a slide. I will drop down. And
Yep.
so, yeah, thank you, Stephen, for that overview. We don't have much time left, and I'll be going very quickly, but please continue to ask questions. And I'm happy to discuss this further beyond the meeting if need be. But if I want to start, where I want to start is in the water side and water distribution and pumping, because I think that really affects everyone. So if you want to take a look at your water system, if you haven't already, I'm sure that it's operating where it needs to be from an operation standpoint. But yeah, if you want energy efficiency, you need to look at it from the energy lens. And there are some really quick things you can do that make a huge difference, like really pulling the pump curves from all of your pumps and making sure they're operating at the highest efficiency ranges, especially if you've had them for a while. Operation may have changed a little bit, and optimizing that is really important. And then pump curve is there on the screen there. We all know how to use those. But I also would say there are a few other things. If you have an older system and you have pumps that the flow is being controlled or throttled by downstream valves, that needs to be reviewed and updated as soon as you can. It is a very energy inefficient way of pumping water, and you should be replacing that kind of method of control with VFDs as soon as you can. Also, basic stuff like trying not to run your pumps in parallel, because that's very inefficient. Enhancing your controls and really looking for the optimal way of sourcing water to your water towers and through the system. So to go on with that a little bit, to speak to what we were talking about a little earlier, I think it's really important to be able to see what's going on with your pumps, especially your bigger pumps. So making it visible. So if you don't have meters or sub-meters on your larger motors, I suggest that you actually install some, and you don't have to go for the financial grade expensive energy meters. You can use amp meters, put them on all the 3 phases, and then they're not even you could get wireless ones, and they can show you what's going on when your pumps are going on and off, and how much of a load that they're carrying, so that when you start optimizing and looking for ways to make sure you're using least amount of energy, you'll have a way of tracking it. Of course, VFDs already track energy, and they can be hooked up to your automation systems if you have them available. And so what you really need to do is look at not just the one pumping station at a time, but after optimizing a pumping station, looking at the whole system. Can you pump from different pumping stations at different times of the day or night? Which pumps are the most efficient? And try, of course, to keep your pumps fully loaded as possible. In general, pumps that are loaded above 65-75% are the most efficient. Anything lower than that, and you're losing process efficiency. Okay. So this is just a little example of someone I was talking to last week, an operations team that had already done a few things with their distribution system. They'd removed some throttle valves downstream of the pumps and replaced the pumps and motors with ones that could handle VFDs, and also had looked at how they were staging the pumping, so it's optimized within some of the pumping stations. The next steps we had discussed were, again, looking at the pump curves and looking at different pumping stations to see if they could coordinate or stage the pumping from the various pumping stations as they were all going to the same water tower. So again, it might take a little bit of time, but it'll be well worth your time to take a look at that, sequencing properly. So I'm going to change over very quickly to wastewater. And I wanted to talk about an example of waste that Stephen spoke about half an hour ago. When you're running more equipment than you require. We walked into an older wastewater treatment plant, and they had several grid chambers, I think 3, and they were using 2, and they had 2 blowers running. And we determined that in actual fact, they'd been doing it for 10 years, and they put it on probably because of an issue within the operation, but then left them on. And we determined that they only really needed one of the 2 pieces of equipment to be run. So we saved a fair bit of energy by just shutting one of those blowers off. And of course, we had to go back to first principles, make sure that we were delivering the right amount of air to the system and it was well maintained. But it just speaks to always questioning in your operation whether or not circumstances have changed and whether or not you really need to be operating everything, all the equipment that you've got, whether that can be trimmed back to just what is needed.
Yeah, that's something that we see time and time again in many types of, not just in these types of operations, but sort of questioning the status quo, right? And it's not a, I don't think it's meant to sort of accuse folks of doing the wrong thing. It's more about, is there a better way to do it, right? And we've done it that way in the past, but maybe things have changed, and we find many opportunities through that type of approach.
So this is just another example of a plant in southern Ontario we were in, and they had the RAS pumps were very, very large. And I mean, that's very typical in most wastewater treatment plants. We plan for volumes that are for years to come. But right now, often the average day flows are much lower than the peaks or the design criteria. So we had a pump that was running at, at 450 liters a second, but we had pared it down to 250 liters a second, and that still was more than we needed. And the system efficiency was quite poor because of that. So what we were able to do in this case, I don't know whether it's in all cases, but most ECAs will allow you to put in an additional pump like a jockey pump if you have physical space for it. They found a pump on site, they installed it that was right sized, and they were able to operate at the right place on the efficiency curve. So they certainly saved energy, but the best thing that they found was they were able to better control their sludge blanket because they were running at the maximum turn down ratio. They had no flexibility to manage their operation. So this gave them an operating range that allowed them to steady state their system. Okay, the elephant in the room in wastewater is aeration, but really it's any kind of system that moves air. It's very inefficient. It's also very necessary. So it could be blowers that you're using for channels, or it could be aeration, or it could be just compressed air in your maintenance shop that you use to blow stuff off. That it's very inefficient. So you have to make sure that you're using it as preciously as you can and using only as much as you need. So there's several areas that you want to focus on that I think are very important, including controls and let's get into it a little bit here. So DO control, you want to make sure that your sensors are maintained. I mean, you may think that just a small amount of drift won't make a big difference, but it does. The location of the sensors are very important. And also, if you have multiple basins and you have a header with automatic control valves on that air header, consider looking at mostly open valve control, which really, I won't go into a detail now, but it really keeps one of the valves open at all times, the one that for the base that needs the most air. And it reduces your system's pressure and improves your performance across the board. The other kinds of things, just making sure if you have fine bubble, diffuser cleaning and maintenance, control valve maintenance, to make sure that they have a full range, and air balancing of your system is really important. Right sizing, turn down ratios. Now,
I remember that one the energy treasure hunt that we did, energy scan we did it outside of Ontario, Andrea, and they got 11% savings out of that MOB control, right? I remember
yes.
that specifically. So yeah, your
Yeah,
10% is pretty close.
It takes a little bit to get it put in, but it's very successful. Energy savings. A few obvious things. You know, you want to, if you have mechanical aeration, then you should be looking at higher efficiency blowers and maybe fine bubble. But if you don't have the funds to do that right away, then make sure you have VFDs on your blowers, make sure you have VFDs on your mechanical aerators, and ensure you have due maintenance. So these are some pictures from various wastewater treatment plants where these are filters to air vanes that were supplying air to the blowers. And you can see that the filters are pretty dirty, and the blowers are still operating. The operation is still running perfectly, but they're running inefficiently. And don't underestimate the amount of energy loss that you achieve through higher pressure drops across dirty filters. And so the other picture I have here is of this red picture with a circle around it. A particular plant had a temporary blower put in place with a temporary tubing, and there was a very small air leak here. And because the operation again was running effectively, they didn't think that it was a big problem, but we calculated that they were losing hundreds and hundreds of dollars of electricity by pushing air through this hole. Instead of putting it through the aeration basins. Speaking to waste as well, really look at your operation. If you have multiple basins, can you operate with one instead of two? And then there are a lot of process-related specific changes you can make that unfortunately I can't cover here, but it's really important to look holistically. Including your primary clarifier performance. I mean, if you make sure you knuckle down and make sure that that's really tight, lowering the BOD up front, of course, reduces aeration requirements, which then, saves you a lot of money.
So Andrea, there was a couple of questions. Jesse, I answered your question about red screen being able to simulate lowering DO. Not directly. There may be, we can talk about that one, but I would say not directly. Max wanted a bit more information about MOV, maybe towards the end. But there is a question from Hugh. It is my understanding that if you are over aerating in your BAF and then lower it, you can increase your N2O emissions. Is that accurate? I believe you've talked
yes.
about this one before.
Oh, okay. So sorry, I can't see the question, but I'll repeat it to make sure I got it right. So if you over aerate, you can lower your N2O or N2.
No, if you're over aerating, but then you lower it, you could have the impact of increasing your N2O.
Yes, that's very correct. And actually, it's a very good question. So what he's talking about is nitrous oxide, which is a greenhouse gas emissions that evolve off of your aeration basins when there's incomplete transition of ammonias. And what happens is that happens more as you reduce your DO in your plant. So you have to be very careful you don't reduce your DO too far, because it could increase that. And the challenge is that right now most plants don't measure it, so it's very hard to often measure how much the is evolving off your tanks. So So it is a balancing act, and I'm happy to discuss that a little bit more offline or after this session.
Okay. Go ahead.
All right, so I'm going to go through this. Actually, these are various different aeration technologies. I'm not going to go through this at the moment, but obviously you want to put on variable speed drives on your blower technologies, and if you can move towards the turbo blowers, that's probably your best endpoint eventually. And there are numerous design considerations that we unfortunately don't have an awful lot of time to go through right now. But you have to look at your summer and winter loads. Go back up. You want to look at what type of bearings you might want. And there are some advantages and disadvantages and limitations to blowers as well, turbo blowers. So happy to do that for anyone who would like a further discussion. We can get into that later. But we need to get into support systems. So Stephen, do you want to do an overview?
Yeah, I think, these systems are really not unusual to many people. Obviously, depending on the type of plant, you can actually run a lot of air for ventilation. So moving that air, and if the space has to be heated or at least tempered anyway, that can require a lot of heat, either electrically or from natural gas. There are opportunities, obviously, to do some heat reclaim. Controls are always a good one. Again, I think what you're finding, and you've got a few slides later on to speak to this, is a lot of times heating is not well controlled, and that's an expensive situation, but it can be remedied for good savings. A lot of the other things you'll talk about, Andrea, in terms of compressed air measures. Again, compressed air is extremely expensive. 100-pound air is about 5% efficient, right? So if you want to use, you're buying electricity even cheaply at 10 cents a kilowatt hour at 5% efficiency, that means your compressed air is worth $2 a kilowatt hour, right? So do you really need to use compressed air? Can you find something else to do the same job? We've seen that in many situations where eliminating the use of compressed air, going by another means, it's actually a lot cheaper, a lot less energy. And then there's the energy recovery from various different sources within the plant. So again, don't ignore these systems because they tend to get overlooked at times in the focus on the process. There's good opportunities here, as Andrea will show us.
Yeah, that's great. Thank you. So we're just going to talk a little bit about some opportunities that I saw in various plants regarding the support systems. And I wanted to talk about HVAC controls and not to underestimate the contribution of electric heating has on the overall demand of the plant. So this is just a chart that was 5-minute increments. This is the full plant, so all the process equipment running along. And then at the end of October, there was a step change, 140 kilowatt step change in demand. And we determined that was really just putting the electric heat on that day caused that steep jump. And what you can see from plotting this data and thinking about how systems work, because we could see such a steep step change, it really told us that the control systems weren't working. So the heating systems weren't coming on gradually as heat was required to maintain the space temperatures. They were all on or all off. And so the plant did a fair bit of work to replace the controls on the units themselves with programmable thermostats, and they were able to drop that substantially. Another way that plotting data so you can see it visually makes a big difference. Now, this is natural gas systems. But it also, oftentimes when you save natural gas, you're also going to save electricity. And in this case, this is a plant that had 3 different gas lines, a boiler line, a line of natural gas to the boiler, their new headworks building, and to an office. And The new headworks was using over double the amount of natural gas that the digesters required for heating, and should have been in the same, should have been closer to what the office was using. So we took a look at it, and there were some very small things that we had to do, which made a big difference. One of the thermostats was accidentally located in an unheated staircase instead of in the room, so it needed to be moved over. And I believe it because they decided not to put in a explosion-proof thermostat, so they had to locate it in the stairwell. So we replaced it with an explosion-proof thermostat and put it in the right space, and they were able to reduce their natural gas significantly. In addition, we looked at ventilation. The ventilation needed to be much higher than other spaces on site. However, in this case, it was over-designed, and they were doing many air exchanges that they didn't require. So they were in the middle of the winter. You can imagine when it's minus 15, they were pushing out a whole bunch of warm air and then having to reheat fresh air unnecessarily.
So, Andrea, there was a point from Jesse, which kind of related to what you're talking about here, is that NFPA requirements typically unnecessarily increase HVAC energy use. That is meeting, I take that to be fire prevention. Meeting fire prevention codes does increase requirement for ventilation, things like that. Did you have any comment against that one? Yeah.
That's a very good point. And actually, you're right. And in this case, we worked with the fire department and the codes, and were able to determine that the ventilation, it was a very new building, and the engineer that developed it was well over what was required by the fire department. And that's right, it is determined by the fire safety code.
Yeah. So check it, challenge it, but you never
hurts to ask.
Yeah, it never hurts to ask. Thanks, Jesse, for bringing that up.
This is another one where some systems were running when they didn't need to. And basically, it was a plant that had a bypass system, but it had a full building and equipment for bypasses. And for those people that aren't in wastewater, that's when there's a large rainfall event and the volume is too high for the plant to handle through the main system. So there's a bypass system of various types to manage that extra volume. And in this case, the plant would use it about 20 days a year. They had about 12 or 13 events a year. And what we did was some sub-metering. We simply slapped a meter on the panel for that particular building and ran it for a couple of weeks. And we found that the system was running over 50 kilowatts of energy, even when it wasn't in operation. And so we were able to relook at it and question why when the building is shut down. And we found some odor control systems that didn't need to run and some other various things that just hadn't been controlled properly to shut down when not needed. And they were able to save a fair bit on consumption and demand savings. And there's another thing that was really nice about this one is that because it was consistently running through the summertime, they were also able to improve their global adjustment peaks. So actually, the following year.
Yeah, I was just going to say that in 30 kilowatts, each peak is worth about $300, right? So 30 kilowatts on all 5 peaks, right, would be, about $300 on all 5 peaks, $60 per peak. So that would be about $18,000 a year.
Yeah.
Wow, on top of the energy and the local demand. Wow. And again, there's a couple of times when you said putting some meters in, and that's what the person from Z3 earlier talked about, is the use of meters, sub-metering within plants. So, always, these things can pay for themselves pretty quick in these types of situations. So.
So just a few pictures of some things. I'm sure that they're not in all places, but yeah, these are kind of unfortunate examples that we found. One is on the left is just it's pretty typical. It's electrical unit heater, and you'll see the dial that's right on the heater there. Those are the dials that typically stop working after 1.5 years or 2 years, and they don't give you any fine control. So it's really great if you can slap on a digital thermostat that's programmable. The other point is that oftentimes if you don't have a digital thermostat, you can't set the temperatures very easily. And often these buildings are unoccupied most of the time. So they don't need to be at 21 degrees C in the winter. They could be at 16 or 17. The other pictures on the right-hand side are just maintenance issues in HVAC systems. And some of the older plants I've been in, it can be really difficult to get on some of the roofs. And as such, if you don't have a regular HVAC contract with someone, sometimes these things can happen where you have holes in your ventilation system, and that of course is going to cost you a fortune in natural gas and electricity as well.
So Andrew, there's a question from Sky here. Could I explain again about the value of each peak for the GA? So what it comes down to is if you look at your global adjustment, your peak demand factor calculation, you can go and get the details from your own, PDF calculation, but it turns out that each peak is worth about $60, right? So if you hit all 5 of them, that's about $300, right? So the idea here is if you can drop those peaks down, each one is worth $60 roughly. Everyone's specific, but that's just a round number, at $300 for all 5 of them. Hopefully that helps guide. Per kilowatt, that's right. $360 per kilowatt for each peak, times 5 peaks is $300 per kilowatt for all 5 peaks.
Okay, great. That's awesome. So I'd be remiss if I didn't talk about building envelope on water and wastewater plants, whether it's just fixing the gaps around doors or in older facilities, just windows that can be left open that are really hard to reach, that that don't end up being closed in the wintertime. And of course, any single pane windows need to be replaced because they don't have thermal integrity. And even 2-pane windows, fenestrations, can have problems with infiltration if they're not maintained. So looking into that is important, especially if you're heating through electricity for cost, or natural gas. If you're heating, it'll reduce greenhouse gas emissions as you carve back that natural gas use. I wanted to do one thing, page up, one other item that seems like it wouldn't be a big deal, but if you have any buildings that are 2-story or that high bay buildings, it's really important to have destratification fans. If you have them, make sure you're using them in the wintertime. If you don't have them, they're not that expensive to install, and they actually save a significant amount of heat energy by pushing that hot air at the ceiling down to where humans are working. And I've done a fair number of studies in various different buildings, and it's one of the most cost-efficient ways of reducing your heating bill.
And two things, you can calculate that using red screen. And also, if you're considering a solar wall, which is actually, they work very well in wastewater treatment plants too. I have a case study from northern Saskatchewan, but you've got a picture of a solar wall later, Andrea. A solar wall, one of the ways that it also contributes is that it implicitly destratifies the air in the space typically. So kind of a double opportunity there.
Yeah, that's excellent. So I don't have much time here, but I'm going to flip over to other resources just for a second. Water consumption. Really, sometimes this gets lost, whether it's effluent water in a wastewater treatment plant or whether it's seal water in a water treatment plant. Anywhere the process is using water, you're also using energy to convey or pump that water to the systems. And in this case, we had an example where we had a compact conveyor and headworks, and we just noticed that the water was on even when that conveyor wasn't running, and we were able to turn that off. We also found that they were using potable water instead of effluent water, and the charges were extremely high. So we were able to save by just observing when things were working and updating controls.
Yeah, one of your previous examples was seal replacement. I did a calculation on it. It's about $25,000 a year in potable water potentially. So
to change from water-cooled seal to a mechanical
seal. Yep.
This is another one, basically putting a meter on the effluent pumps on site. And we just did it for a week, and we found that the cycling of the pump was much more frequent than expected. We're able to find several leaks, fix them, and we were able to reduce the energy on those pumps and by 25%. But more importantly, we were able to reduce the amount of cycling, which will improve the life of those pumps.
And 4 minutes.
4 minutes? Okay, so I'll just quickly go through here. We'd be remiss if I didn't talk about renewable energy sources, considering solar walls. They let you look those up. I mean, they're very, very simple but effective. No moving parts, and they take preheated air from the side of your building and use it to preheat heating air. Second would be microturbines. If you have a large drop at the end of your wastewater treatment plant between the outfall and the discharge source, you can make use of that drop through and turn it into electricity. And they've done that at Clarkson wastewater treatment plant if you want to take a quick peek later on.
And both of those things can be modeled in red screen.
Yeah. Oh, yeah, exactly.
Heat recovery,
of course,
as well.
Yeah. And the last one here is just recovering heat from effluent. And what we see here is a big unit. There is a lot of heat energy that is exiting the facilities through the effluent, and that can be captured. And in some wastewater treatment plants, they're using it to preheat membrane flush water. But we're also seeing it in urban settings. I encourage you to take a look at the Toronto Western Hospital program, where they're using a sanitary sewer truck to pull heat from and heat the facility. So I think that's it for me, Stephen. Thank you very much. Sorry it was so quick.
No problem. You want to go to the next slide there, and Mintu can take over. She'll remind us about the coaching, and go ahead, Mintu.
Thank you, Andrea. So for the coaching, before talking about the coaching, I'm just going to talk about the resources that we have on the IESO website. So we have multiple resources. Other webinars are there, and fact sheets. You can have MNV templates and other practical guides. And for the one-on-one coaching, if you have an energy efficiency project and you want to talk to an expert, this is the opportunity to talk with an expert, directly. If you have any question, if you want to go through your project or you have any opportunity and you want to talk about it, so feel free to reach out. I'll post the link in the chat. I just wanted to go quickly because I saw other questions that were maybe interesting to mention here. So I'm gonna post it, but before that, yeah. So the other question was from Jesse, I think. Do solar panels typically provide better return than solar wall? I think it was for Andrea.
Yeah, that's a good. I mean, that's a hard one to answer. I'd have to model that in the situation, but I think the solar electric might be if you've got a load. But again, I'm going to hedge my answer on that one without doing the analysis. I've seen some pretty quick returns on solar walls, so that's why I'm a little hesitant. Yeah, because the solar wall does give you the destratification as well.
I also think that solar walls are terrific when you actually get to a point where you want to do any work on the cladding of your building. So maybe don't put it in right away, but do it when you're actually having to refurbish the outside of your building anyway. Then it becomes very cost effective.
Yeah, at that point, the solar wall is definitely going to win. So the one thing actually I'll just mention too, like Christian talked about earlier about the workshops. If you go to Save on Energy there is a 75% incentive available for dollars to cents workshops, and Andrea and Christian and I have delivered a number of those. So that's a training opportunity. 75% incentive. I'm not sure how long that's going to continue, but it is available now. So.
I don't know if you still have time. There was like 2 questions that we wanted to wait at the end to actually. So the first one was the dissolved air filtration is used extensively in water and wastewater treatment. Are you aware of this technology being used in other types of process as an energy saving option? So I think it was for Andrea too, this one.
Yeah, and I don't think we have time to go through it, but I think that was from Max.
Yeah,
Max, yeah.
And I can contact you after that words, and we can.
And Max was also interested in the
most open valve.
most open valve.
Yeah,
So
exactly.
And Prolar turned down. Okay.
there you go, Max. You
And
got a
he-
date with Andrea.
Yeah, Max,
So
you can
thank you
send
very
me an
much.
email
I
when
think
you're
we can
available.
put the other slide where there were your emails, so they can reach out to you.
Oh yes, okay. So
yeah.
here,
Yeah, you can reach out to us directly, but if you in that form for the coaching, if you just put Andrea or my name, then that'll get directed to us appropriately. So
Exactly.
but you can call us directly as well, and or email us. We're happy to help. Send all the tough questions to Andrea. No, just kidding.
So thank you, everyone. As I said, also if you have a request for having a red screen key, you can reach out to us. We can provide a key for you to have the red screen for you to have it. And also, the webinar is recorded and it will be online. And also we will send also the PDF so you can have it. Thank you, everyone.
Thank you. One
Thank
last
you.
slide there, Andrea.
Thanks, guys.
Thank
All right,
you.
take care.
Bye.
Bye-bye now.